In the last problems, we added or subtracted a number to a function after we had done what the parent function told us to do. Here, we're going to take a look at what happens if we add or subtract a number before we plug into the parent function. All right, and I sort of am giving it away here. That's going to give us a horizontal translation or a shift. So for our examples, we're going to use the parent function, which is the square root function. So hopefully that's one that you're familiar with by now. That has a starting point at the origin, and it just curves up and to the right, getting less steep as we go. Just want to remind you that if we are plotting points to get that, we want to be very strategic about the points that we plot. First of all, the domain, because we're taking an even root, the domain only consists of non-negative numbers. So the first value in the domain is 0, so I definitely want to plot that point because that's where the graph is going to start. And then I just chose numbers where the square root works out very nicely, so that the y values we're getting are just 0, 1, 2, and 3. Now, I just sort of drew this freehand. Plotting those points can make it so that I get the scale a little more accurate, although I think that was fairly close. 4, 2, 5, 6, 7, 8, 9, 3 is going to be over here. Okay, so there's our parent function. Now, for 1b, what we're going to do is we're going to sketch g of x, which is going to be the square root of x plus 2. So we're adding 2 to our x values, but we're adding 2, well, to x, rather than adding 2 to the y value that we get after plugging into the function. We're adding 2 and then taking the square root of that. So I'm going to create a slightly different table of values. Now, if you've got the worksheet, you've got that there already. What I want to do is take advantage of the fact that I know that if this is what I plug in, this is what I will get out. These are the things that I want to be taking the square root of. So those are the things I want to be plugging into the parent function. But what I'm plugging into the parent function is x plus 2. So I'm going to modify my table of values here. I'm going to create a table where I'm going to list x, x plus 2, and the square root of x plus 2. And I want this column, which is the thing I'm taking the square root of, to be these nice numbers. So I'm going to make this 0, 1, 4, and 9. Then I'll be able to say that's going to give me my nice y values. Now, if you've got the worksheet printed out, you can see that that's what I gave you. I didn't give you the x values. I gave you the x plus 2 values. If you're just copying this onto paper by yourself, that's fine. But I would suggest you somehow indicate that this is where you start. Because if you just write down the table, you're going to think we started here. But the trick is to start here with the input to the parent function being the original inputs to the parent function. Those things that we said were going to give us the nice values. Then it's easy to take the square roots because I'm going to get those same y values, 0, 1, 2, and 3. So the square roots that I'm getting, the y values here, are the same as the y values here. Now what I need to do is figure out what does x need to be in order to make x plus 2 be these nice numbers. So that involves just doing a little bit of algebra. Here I can say if x plus 2 is equal to 0, let's solve that for x. So I would subtract 2 from both sides, and x would be negative 2. Here, this is saying x plus 2 is going to equal 1. Well, if x plus 2 is equal to 1, to solve for x, I'm going to subtract the 2 over, and I'm going to get x equals negative 1. Here, we're saying that x plus 2 is equal to 4. So we can subtract the 2 over, and so x is 2. And here we're saying x plus 2 equals 9. Again, subtracting that 2 over to solve for x, we'll get x equals 7. So now, if I'm plotting points, this middle column, which is what I started with, this is just a helper column. What I'm plotting is x, and then the formula for g of x was root x plus 2. So I'm going to have this point negative 2, 0. I'm going to have a point negative 1, 1. I'm going to have a point 2, 2. And you can see what's happening. Basically, these points that I plotted that were on the parent function, I'm now keeping the same y value, but just sliding the points 2 units to the left. Okay, so this point here, which was at 9, 3, now gets shifted to the left, so it's at 7, 3. And I can connect those dots. And I have this function here. So, changing the input to the parent function, adding a number before I did the parent function, in this case before I took the square root, that was changing the input. Not a huge surprise that that changes things horizontally. But it may be a little bit surprising that when we added 2, we didn't move things 2 to the right, which would be in the positive direction. We moved things 2 to the left. So adding 2 actually shifted things in the negative direction. It shifted it 2 units to the left. And we can see why that's the case. Because if we know what this is, we had to solve for what x was. We knew we wanted to have these nice numbers in order to get the same y values that we had gotten previously. But then we knew what x plus 2 was. To solve for x, we had to undo the addition of 2. And when we undo addition, we're essentially subtracting. Okay, so I want you folks to do part C. So part C, you're going to be sketching, let's see, where did I put it? Here we go, 1C. You're going to be sketching h of x, which is the square root of x minus 4. So we're subtracting a number, and again, we're doing it before we plug into the square root function. So the table of values that you're going to use will have x, x minus 4, and root x minus 4. And again, the key here is that I want this, the thing that I'm plugging into the square root function, I want that to be these nice numbers that are perfect squares. That's what's going to ensure that I get nice square roots. In fact, we can go ahead and say I'm going to get the same y values of 0, 1, 2, and 3. Your job is to figure out what x values go with those y values. So complete that table of values, sketch the graph, pause the video while you do that, and then tune back in and we'll compare answers. I've gone ahead and completed the table. I did this in green. Notice if x minus 4 is equal to these numbers, then in solving for x, I have x minus 4 equals 0. To solve for x, I need to undo that subtraction. So I'm going to add 4 over. So I get x equals 4. So all of these x values end up being just 4 more than what these are. And these were the x values that we used on the parent function to get those nice points. So what that means is that this black graph was our parent function. We've shifted it 4 units to the right. So this point got shifted 4 units over. Here was the point 1, 1. That got shifted 4 units to the right. That becomes the point, 5, 1. Here was the point 4, 2. That got shifted 4 units to the right. That became the point 8, 2. So everything got shifted 4 units to the right. Feels a little bit counterintuitive because when I'm subtracting, I want to think that's going in the negative direction. But the idea is if I add or subtract a number before I plug into the parent function, that's telling me what I'm plugging in here. To solve for what I'm plugging in as x, I need to undo that addition or subtraction. So it's actually going to move things in the opposite direction. Subtracting a number moves things in the positive direction. Adding a number moves things in the negative direction.